Hey there, hope you're having a wonderful day. So in the previous video, we went over operator overloading, which is a form of polymorphism. It provides us functionalities with operators instead of method calls. And we did so for this fraction class that we've been working on. So if I expand this, you can see the fraction class has two data members, numerator and denominator. We have our constructor, the setters and getters for numerator, and the setter and getter for denominator. And in the previous few videos, we added functionality for adding, subtracting, multiplying, and dividing fractions. But I removed those functionalities just for this video because I don't want the code to be too crowded. So currently we just have a representation of a fraction. So numerator and denominator. And if I scroll back down, you can see I've created 5 instances of fraction. So we have 5 fractions. And in this video, we're going to compare these fractions. So for comparison, we need to overload the comparison operators, which include less than or equal to, greater than equal to, and not equal to. And overloading these operators is very important because it expands the functionality of our fraction class. Aside from just directly comparing if one fraction is greater or less than or equal to another fraction, we can actually overload the less than operator for sorting. So let's say I had a vector of fractions. So I'm going to scroll up, and over here, I'm going to include vector, and I'll also include the algorithm library. So this library has functionalities for sorting, searching. If you want to learn more about this library, I have a video on that on my channel, and I'll link it in the description below. Now let's go back down. So in our main function, let's say I create a vector of fractions. So vector of fraction, I'll call this fractions, and we can initialize this with frac1, frac2, frac3, frac4, and frac5. And what I'm going to do is iterate through the fractions vector and print out every single one. So I can do for const fraction. So this is const reference of fraction of fractions. I'm going to call fraction dot print fraction. So this is a method that we define up here. And if I scroll back down, let's save and run the program. You can see we print out the fractions, and this is ordered by insertion. So frac1 comes first and frac5 comes last. Now, what if I want to sort this vector of fractions? So to sort, I would have to call the sort function from the algorithm library. So sort, and I would pass in the iterator for fractions.begin, fractions.end. And if I copy this, paste it over here, and here I'm going to add before sorting. And let's copy this. And over here, I'll change it to after sorting. So if I save and run the program, you can see we get an error. And that is because in order to call sort, we need to overload the less than operator for comparison. And if you think about it, sorting refers to organizing a list in ascending order. So basically, if we were to sort a vector of fractions, we need to determine how to move the fractions around. And to move them around, we would put the smaller one in front of the bigger one. So we would put the fraction that is less than another fraction in front of it. So in order to do the sort, we need to overload the less than operator. And overloading the operator is very simple. The syntax is pretty much the same as creating a method. So for the return type for addition, subtraction, multiplication, and division, we returned a fraction. Now for comparison operators, we would be returning a boolean. So bool, and we're going to type operator less than symbol. So basically, to overload the operator, you just type in operator for the method name, followed by the operator symbol. And here, I'm going to take in another fraction. So in this case, I'll take in the fraction with const reference. And I'm going to call it other. And we need to return the boolean. So how do we define whether one fraction is smaller than the other? So let's say, for example, I want to compare 11 over 15 and 2 over 3, which is bigger or which is smaller. Well, I can't directly compare it like so because the denominators are different. So I need to cross multiply. So if I want to compare if 11 or 15 is less than 2 or 3, I will have to cross multiply. And so we take 3 and multiply top and bottom, and we get 33 over 45 less than, and we take 15 and multiply top and bottom over here, so we get 30 over 45. So now that the denominators are the same, we just need to compare the new numerators, and in this case, this will evaluate to false, okay? So over here, let's return numerator times other dot denominator is less than other dot numerator times denominator. All right, so this is how you can compare whether one fraction is smaller than the other fraction. So if I save and run the program now, you can see before sorting, we have this order, and after sorting, we have this order. Okay, so now we can sort a vector of fractions since we overloaded the less than operator. All right, so now we have support for sorting a vector of fractions. So I'm going to get rid of this and this as well. Okay, now that we have the less than operator, why don't we add the other operators? So I'm going to just copy this, paste it over here, change this to greater than, and this one over here as well. And I can just copy this, paste it over here, change this to less than or equal to, and over here, less than or equal to, and I can copy this, paste it over here, change this to greater than or equal to, and greater than or equal to. Okay, so why don't we test these operations? So down here, I'm going to add a few more print statements. So let's do cout. And I'm going to compare 11 over 15 is less than 2 over 3. And for that, I'm going to add parentheses. Frac 1 is less than frac 2. And I'm just going to comment out this vector of fractions for now. So let's save and run a program. And you can see 11 over 15 being less than 2/3 is false since we have 0 over here. And that is because after we do the cross multiplication, we can clearly see that 33 over 45 is not less than 30 over 45. And let's copy and paste this over here and let's change it to greater than. So I'm going to change this to greater than and let's save and run a program. And now you can see for greater than, the opposite is true. 11 over 15 is greater than 2 over 3. And I can change this to greater than or equal to, and this as well. So if I save and run the program, you can see we get true. 11 over 15 is greater than or equal to 2 over 3. All right, so the functionalities work for less than and greater than. So I'm going to remove this. Now, what about equality? So equal to or not equal to. So we haven't overloaded the operators for equality. And if I uncomment this out, and let's say I want to count the number of occurrences for a fraction. So over here, I'll do cout, count the number of occurrences for 11 over 15. And I call the count function from the algorithm library. So count fractions.begin, fractions.end, and I pass in frac1. So basically, I'm trying to count the number of times frac1 appears in this fractions vector. So if I save and run the program now, you can see we get an error. And basically, in order to use the count function, we need to overload the equality operator. And this makes sense because if we want to count the number of occurrences for 11 or 15, and this is our vector, we would have to iterate through each one and make a comparison. Is frac1 equal to 11 or 15? Is frac2 equal to 11 or 15? Is frac3 equal to 11 or 15, and so on. So anytime you do any searching operation, you will need to use the equality comparison operator. And this includes counting, finding, removing. If I want to remove 11 or 15 from the vector fractions, I would have to go through the vector and do a comparison at each index to see if the fraction at each index is equal to 11 or 15. Okay, so let's scroll up, and to do equality, it is very simple. I just need to copy this, paste it over here, change this to equal, and change this over here to equal as well. And while we're at it, let's also do the same for not equal to. So I'm going to copy, paste it over here, change this to not equal, and change this to not equal. Okay, so let's go back down. And now in our main function, if I save and run the program, you can see 11 or 15 occurs one time in this vector. And if I change this to 22 over 30, for example, and I save and run the program, you can see 11 over 15 now occurs 2 times in our vector. And that is because these two are equal. Even though the numerator and denominator values are not the same, the total value of these fractions is equal, okay? And of course, over here, I can do std cout 11 over 15 is not equal to 22 over 30, and I compare frac 1 not equal to frac 2, and I take this and I paste it over here, and let's say I compare it to 5 over 10, for example, then this will be frac 3. If I say and run the program now, you can see 11 over 15 not equal to 22 over 30 is false, whereas 11 over 15 not equal to 5 over 10 is true, okay? And if I change the operator from not equal to equal, then we expect the results to flip. So if I change this to equal and the operator as well, and I save and run the program, you can see the results have flipped, okay? Alright, so that's it for this video. This is operator overloading in C++ for comparison operators. So we provided functionality for these 6 comparison operators, and just as a reminder, if you want to add support for sorting, you would need to overload the less than operator, and if you want to provide support for search related functions such as find, count, remove, you will need to overload the equality operator, okay? So that's it for this video. Hopefully you found this video helpful, and if you did, make sure you give this video a like. If you have any questions, let me know down below in the comments. And as always, if you want to stay up to date for more C++ tutorials like this one, make sure you subscribe to the channel, and I'll see you in the next video. Bye bye.